Hello everyone, welcome to SRV401 File Services Deep Dive. I know it's Friday early afternoon after a very long week for most of you. I'm glad to see that so many of you have not only not left for the airport, but actually made your way here for a level 400 session. As you can see, my name's Ralf Schnell, and you are probably wondering where the other guy is that is mentioned in the schedule. Well, Tres couldn't make it, unfortunately, which is really bad because he was supposed to answer all the difficult technical questions while I was supposed to go around with my hat collecting the money. But lucky you, it's not going to happen that way. Maybe I go around and put my hat at the door so you can't exit without giving any. So it's just going to be me. And to set expectations, I know that some of you will have different expectations about what is actually level 400. We are going to look at some code. I know you are not developers, but still I think it's beneficial to see about transactional NTFS, how actually this is being used within the operating system and how you could make use of that from scripts and other sources. We are going to look into net monitor traces and talk about the networking part of file sharing. Let me actually just bring up the agenda, then you can follow that better. So we're going to start off with a brief look, which is not really level 400, a brief look into file service management. We'll just spend a couple of minutes on that. Then we are going to talk about transactional NTFS. We are going to talk, as I just said, about SMB server message blocks, the file sharing protocol. We will use netmon to look into what is actually going on when I transfer data from A to B. What's the reason for some of the behavior we have seen in the past? What's the reason why we expect this to be way better, way more performant, and way more scalable in the future? And then we'll spend 5 to 10 minutes at the end to cover some other stuff. DFSR, you might probably know already from Windows Server 2003 Release 2. If you don't know DFSR, this is going to be new for you. We are going to talk about offline files and see what happens in XP and Windows Server 2003 if I use offline files and what the changes are from to Vista and Windows Server 2008. And we'll go into one bit of detail with regards to Microsoft cluster services. With that, let's start, and I have to start with a confession. I really like PowerPoint, the product, but I hate slides. So, being from Microsoft, obviously I've brought a couple of hundred slides. If I show them all, that will be around 5 slides per second, so it will almost look like a cartoon animation kind of thing. But I will most likely not use any of them. If you think you need more visual entertainment, then raise your hand and let me know. Otherwise, we'll try to manage without that and use demos instead of slides. I hope you'll like it that way. So let's start with storage management, and I'll switch over to my second demo machine for that. As you can see, this is Windows Server 2008 Release Candidate 0 with Windows Server virtualization. I have a couple of machines I'm using for that demo, and the one I will use right now I've already brought up. I just need to put it full screen. So, as I said, we are going to spend a couple of minutes with regards to file service management. Now, file service management might be the best or the most obvious point where you can see that Microsoft, we have traditionally been a platform company. We have all the bits and pieces that can make up a great file service, but we've actually never provided you with a file service. We've provided you with the platform components. And the way you had to set up a file share and connected with other things like replication, like distributed file system, set security, and so on and so on. You have always been able to do that, of course, but you had to go to a dozen different places to do it. Use command line utilities at the one place, for instance, when you provision storage, when you have to create a LAN in your storage area network, or you have to open this MMC, and that might have been different versions. They might be installed on different servers, on different remote desktops or admin workstations. So it never has been quite that simple to actually do something really essential for most IT infrastructures. So let us simply go through the wizard and see how that changes with Windows Server 2008. So you see right away I have two things I could click on here. I can click on provision storage and provision share. And when I click on provision storage, I'm actually going to get an error message. Now, the reason for that is not that dear old Microsoft really still didn't get it right, and now we are going to get an error message by just clicking on provision storage. The reason is I have one demo notebook here, and guess what? I don't have a storage area network for demo purposes. I tried to convince my manager to give me one and to give me two guys to carry it around with me, but that didn't happen so far. So I don't have iSCSI or a fiber channel attached storage area network or anything the like. What I would need actually is some shared storage environment that supports the virtual disk service, VDS. If you have a virtual disk service compatible driver, then from this place you can actually provision storage. You can create a LAN, you can manage your SAN infrastructure, meaning you can also manage your host bus adapters, your storage area network, fiber channel switches, and so on and so on. You can do all of that from one single place. And most of the enterprise storage vendors today offers VDS compatible drivers for most of all of their equipment. So we can't do that here, but we can just go through this wizard, and you see on the left-hand side we have several tabs here: share folder location, NTFS permissions, share protocols, and so on. There are a couple of things actually missing here, and they are missing for a reason. This wizard is intelligent. It expands as you install more components. On this server, for instance, I did not install the distributed file service or DFS replication. Once I install that, these bits and pieces show up in that wizard automatically. So depending on the infrastructure you have, this wizard will simply adopt to that and allow you to use all the functionality that you have available in your infrastructure without having to go to different places here. Now you see when I either create a new folder or select one that I created, for instance this one here, I have some things that are shown to me at the bottom. For instance, I don't have shadow copies configured here. If I were to use shadow copies or data protection manager, which in turn is using the shadow copy mechanism, then that would be visible from that place. And also high availability, meaning cluster services in our world are not configured. The location which I am using and the virtual server that or the server name that I'm pointing to is a physical server, not a cluster services virtual server. If it were a clustered service, I would see this will be a high availability file share. And again, I could say provision storage, but I'm not going to show you the error message. It's not that interesting. So let's just move on. And you remember all the time when you created file shares that permissions were defaulted to everyone full control. Now that is a thing that is not really best practice. But the thinking behind it simply has been, if someone creates a file share, they most likely will want to have access to it. So what's the only way of guaranteeing that anyone creating a file share actually has access to that file share? Well, let's give everyone full control. That'll work for most environments. I could construct something where everyone full control wouldn't give me access, but that's really hard to do. So that'll work, but now we finally said, okay, I can live with everyone full control, but I can simply change that. We are not going to change that for demo purposes. I just move on. And now I have two protocols installed. I have SMB and I have the network file system. Again, I told my manager I will need a third and fourth notebook for putting Unix on that and stuff like this, so I can actually demonstrate how NFS is going to work. I don't have that either at the moment. But you can see I can select from the protocols that I have installed here, which are SMB and NFS, and put in whatever is appropriate for my purpose. Now I have a shared path. I can put in a description if I want to. And again, I have some things which I've been able to see before, but I had to know where to actually go to do that. For instance, I can see that a user limit is not set. I have maximum allowed, which is the default. By the way, when you created a file share before, try it in Windows Server 2000 and Windows Server 2003, and you don't use the mouse to click around in the wizard, but you use the tab key. One thing that might have happened to one or other of you is actually when you use the tab key to go to all the fields you need to go to, one of the things it does without maybe you noticing it, it sets a maximum user limit to, I think, 8 or 20 or something, a really low number, which is simply because you need to go over those fields where it says no limit and maximum limit. So the tab key brings you from no limit to maximum limit and then to the permissions, if I remember correctly. So with Windows Server 2008, that's not going to happen, but you can change the settings from here. One other thing to note is access-based enumeration is now enabled by default. For those of you who know access-based enumeration, this is going to be a repeat for the rest. Access-based enumeration simply means a user now sees only the objects in a file system that he or she actually has permissions to, which doesn't make sense because it allows you to create more folders, for instance, more file shares in the same path on the same level without having to group them so users can actually find their way through that. For instance, if you had a clustered file service environment and you have a couple of thousand file shares, which happens quite often with our big customers, and they are all under the same folder structure, then actually finding a specific file share can be quite difficult because the list is so long. Access-based enumeration means now you see only the file shares that you actually have access to. So these are the only ones most likely that are going to be of interest of you. On a side note, there used to be a performance penalty of using access-based enumeration in Windows Server 2003, which roughly guesstimate would be around 5% performance decrease when browsing the folder structure, not actually when accessing files. But we would have to run through that algorithm and figuring out what to show you and what not to show you for every time that you browsed through any folder object. And that really has gone away with Windows Server 2008. You're not going to notice any significant difference there. So now we can set the SMB permissions. And again, that used to be a place where we said, well, everyone full control will work great for everyone. So we're just going to do that. Here, we will give you some pre-configured values where you can choose from, or you can simply say, no, I will pick my own thing that fits within the way I do stuff in my infrastructure. So you can set that from here, just use custom share permissions. We are going to go with the default here. And some more things I've installed. And you saw the moment that I picked SMB, for instance, now some options that are relevant to SMB became available. For instance, quota file screening DFS. So I can set a quota policy on here. I can say how much space do I have for a certain object. File screening, the same stuff. DFS namespace publishing, I can integrate this within a DFS namespace or within DFS replication. You know that with DFS, starting from Windows Server 2003 Release 2, replication and the namespace are not actually tied together anymore. You can set up a namespace without replication, you can set up replication without a namespace, or you can do both of that or none of that, obviously. So that's really all I wanted to show you with regards to the management bit of this. And with that, we will move on to the next topic, which is transactional NTFS. And we will start by saying yes to this question, and then move to another demo machine. And this is actually the bit where I will do my first really, really complicated demo. So this is going to be very demanding. I need your full concentration, which is a lot to ask directly after lunch, I know that. I need complete silence in the room. I need you all to focus on what's happening here. So we have a Windows Server 2008, and obviously that is running. It's a virtual machine on Windows Server Virtualization, or Hyper-V. Actually, I have to get used to that name. I have to practice that some more. So that's a Hyper-V guest on here, and it's running. It's doing stuff in the background as we are actually used to for servers. And now there is a feature within Windows Server Virtualization, or Hyper-V, which is brand new. I think that will distinguish us from all the competition. we actually can do something which I believe no one else can, and that is we can trip over the power cord. I don't know if you can do that in VMware or Xen, I have no idea, but I think we are the only ones that can actually trip over the power cord for a virtual guest. So we just did that. Our guest, as you can see, is quite dead by now. And the question now becomes, besides the guest being dead, our Windows Server 2008, what happens next? Is that good or bad? Well, obviously it's bad because the server is down, but we can simply restart it, right? So what happens if I restart that server? Will it come up or will it not come up? How many of you think it will actually start? Most of you, anyone thinks it will not start? Anyone ever experienced such a situation? Someone, half a person, something like that. We actually did a test like this accidentally when we built a new Microsoft campus in Munich. That's a couple of years ago. We built a new campus, we built a new data center, we built completely redundant power, 2 separate power supplies from the outside coming into that, both of them capable of running the entire data center on their own, 2 diesel generators, 2 battery blocks, each of them supporting the whole data center for 1 hour each. Totally redundant, so nothing could possibly go wrong, right? Enough diesel to run for a week. So what happened was that both of the outside power lines went down simultaneously, and that was a software problem in the power current switching system that controlled those power lines. So someone actually flipped the switch, so the outside power was down to the data center, and then the battery blocks kicked in as they were supposed to do. The problem with that was that the alarm from the battery blocks to the security office, which was supposed to then switch on the diesel generators manually, that alarm went off, but it terminated in some printer in a back room. So out of that printer came a piece of paper saying, alarm, the outside power has just gone down, please switch on the generators. But guess what, there was no one in the back room. So after an hour and something, the batteries decided that they are now drowned, and they really properly shut down the entire data center. So it was just black like this. And the really bad part was that was the last Sunday of the last weekend of the Munich Oktoberfest. You know the Oktoberfest? It's where all those folks gather on the Wiesn in Munich and drink all that orange juice and mineral water. So my entire team was there. I was the only one not being on the Oktoberfest because I had to catch a 6 a.m. flight the next morning to do some presentation somewhere in Eastern Europe. So at 2 in the morning, my phone rang and they said, Ralph, can you just go there and, fix things? Because we are all drunk. So I went there and we had around 120 servers that all went down and the power went out. And most of them actually started up. One of the few that did not start up was actually a domain controller. So what was the reason why this server did not start up? Well, if I had FileMon on here, do you know FileMon from sysinternals formerly? You run that on a normal server, even if it's not under any load, and you know what the reason is. Why server sometimes decide to not boot anymore if you trip over the power cord. The reason is we are writing all the time. We're writing to the file system, we are writing to the registry. And a traditional write, as we used to do it, up and including to Windows Server 2003 R2, really means on the application layer, we decide that we need to change a certain file that is resident in memory from this state to that state. And this translates down the storage stack to the hardware level, where actually we say, okay, there is a couple of blocks over here and a couple of blocks over there, and we need to change these ones to 0, and we actually need to change this 0 to a 1. So we just say, okay, we need to change this and this and this, so let's go do it. Flip this bit, flip this bit, flip this bit. And if between flipping this and the rest, we cut the power or we get a blue screen or whatever may be the reason of the interruption, we are actually in a corrupt state. And that can happen to the file system and it can happen to the registry. So to put it simply, Before Windows Server 2008 and Windows Vista, which also has transactional file system and transactional NTFS implemented for anything that the operating system writes for both, before that, we never could transact any writes. We never said, okay, let's first save the state to some other place, then try to do our write, and then say, okay, transaction complete, as any normal database would do. SQL Server does this, but Access, for instance, is not transactional, which is one of the reasons why SQL is so much more robust and so much more scalable than Access. So back to what we do in the operating system, we now transact anything that the operating system writes. Of course, we provide a framework for you or any third-party vendor to use that capability to transact writes to the file system, to the registry, and do this, for instance, for application installations, but we don't do this out of the box. So if you install something on Vista or you install something on Windows Server 2008, we are not going to do this in a transactional fashion unless the setup in this example actually initiates a transactional write. So let's take a look at how this happens, and I'll switch over to my Vista machine. As you can see in the background, that's Vista Ultimate with Dream Scene running, and I know some of you are going to come back to me after the session, give me some heat about wasting precious energy. I have to confess, I like the background. So this is what I use, and actually I'm going to start a little application which a good colleague of me actually put together, Jason Olson. If any of you know him, great guy to know. Go to his blog, you can get any sort of information about transactions and many other things from him. So what this really does is I have a start button where I can create a transaction scope, meaning I say I want to do something transactional, and then I have two paths. I can either say, okay, ignore the transaction scope, just write, and we're actually going to write 3 files to 3 different locations, or I can say I use the transaction scope and I'm going to write these 3 files within one single transaction. That's an important thing to notice. A transaction doesn't mean I write one file or one registry key and I do this within a transaction. It actually means I can combine multiple files or multiple changes to multiple files, registry writes into a database, writes to totally different places using mechanisms like the distributed transaction coordinator, for instance, or SQL transactional writes, all within one transaction scope. This is what makes this so powerful. I'm not limited to one single box or just to the file system. So I can either say do it traditionally or do it transacted, and then if I do it in a transaction, I can actually say I want to roll that back instead of write it. So let's just have a look at what that will result in. I have 3 locations here, which when I start that application are cleaned up for me, and they're all empty, as you see. So I will now say start, and you can probably read that. It says transaction started. Then I do a normal write, and you can see I have 3 non-transacted files created for me in those locations. The moment that I click the button, or a few seconds after I click the button, those 3 appeared. And then, just for the sake of this very simple code, I have to click commit, although I didn't really use the transaction scope, but just to be able to continue with my demo, I have to actually throw it away and create a new one. So that was a traditional write. If I go through the same thing, I click start, it says transaction started, I do a transacted write. Now we are just going to wait until it says created transacted files, and we go through these same locations, and there is no transacted file there, although all 3 have been written already. But no one outside our transaction scope can actually see them, which is another really, really important point about transactions. If you imagine that you write these files, and in case you have to roll back or you decide to roll back for whatever reason, you just delete them again, but those files or any of these have been visible to anyone else, then probably this anyone else could interact with them in any way, shape, or form. So if I do this and then I say, well, roll back, then maybe I'm deleting something for someone else. So that can't happen. A transaction has to be completely isolated. Any part of that transaction has to be hidden from everyone else until I say, let's commit this. So we'll do this. There's my mouse. And now I've been talking too long, so that's the reason for this. So I have to cancel this and do it again and not talk so long, and then it'll actually work. We create the transacted files and we say commit, and there they are. So there was a simple timeout, and the code to this is really, really simple. There's no exception handling or whatsoever in there. So you see the files appeared actually the moment I said commit. So now what will happen if we say, well, that was all nice, but I had access to these locations. Now let's go ahead and take permissions away for this guy here. You know, he didn't behave so well. He shouldn't have access to that. So let's give him read permissions only and say start. And say write a non-transacted file, a normal traditional write. So you see I have an error message, and again there's no exception handling code in there for the sake of you actually seeing what happens under the hood. So that's on purpose. It says basically the access to this path where I just took permissions away is denied. So I can say quit or I can say continue, doesn't matter. I interrupted the sequence of writing 3 files, which means in this folder, file store, I did have permissions, and there is my non-transacted file. On this one here, file store 2, I took the permissions away. The transacted file from the example before is still there, but the non-transacted file could not be written because I just took my permissions away. And the application actually got interrupted by this error message. So it did not even try to write to the 3rd location where I actually still do have permissions. Which means if that would be an application installation, I would now be in a non-consistent state. And probably you came across some of these. They installed something and tried to uninstall it, and you couldn't uninstall it anymore because some part you needed to uninstall it was removed already or corrupted in whatever way. So you're left with a lot of garbage which you now have to manually clean up. If I do the same thing with a transacted file write, I actually get the same thing. It just says the transaction has aborted. And then the files that I have in here, they have been created in the last run where I created the transactional files. But now what the application did is it didn't commit any part of the files because it didn't commit the transaction. So the files have been written in a hidden way, and because the transaction couldn't complete in its entirety, it just got rolled back all the way. So none of the 3 files have now been written. So that are the important bits of working in a transacted fashion. It has to be isolated, and it has to either succeed all the way or it has to not happen any part of it. So looking at the code real quick, and that is actually Visual Studio 2008. And me not being a developer, I think the main message here is if I can understand what that means, you certainly can way better than I do. So I'm not a developer at all. So what that really does is I have some information that really is about where do I write which file. Really simple. I have a region that's called constructors where I clean up the environment. That really says if I double click and open up that little GUI, then it will check are those folders created and is there anything in them, and if there is anything in them, it'll just delete it. That's all it does. And then really all that's left is what actually happens if I click which of the buttons, and that's transaction management. And it doesn't really get any more complicated than that. All it does is, here is the start of the region. If I click the start button over here, it will create a new transaction scope. That's all. That's even less code that I would need to do a traditional write in a non-transacted environment. If I did that, I would need more code than doing it transacted or non-transacted now with Windows Server 2008 or Windows Vista. I just have to say I create a new transaction scope, and then I have to say anything I write, I want to use this transaction scope. And I could create multiple scopes now if I wanted to. In this case, I just created one. And then if I do a file write, which I do down here, you see that I say new streamwriter transacted file.open. That means point this to the transaction scope. And all the rest, all this, where do I hide my file from the outside world, from anyone outside this transaction? This is all done for us by Vista or by Windows Server 2008. I don't need to even think about that. All I need to do is open a transaction scope, write something inside that scope, and then commit the scope. And if anything goes wrong in between, then the whole mechanism of rolling that back and cleaning that up is all taken care of automatically. So with that, we'll move on, unless there are any urgent questions about transactional NTFS right now, but we'll leave around 15 minutes for question and answers later on. And I am going to switch over to my other demo machine here. Let me see. I know that you probably think all that switching over demo environments is a waste of time and we should be better organized. The truth is, as you know, we are streaming live to the outside world. And the times where I actually switch between demo machines is when those folks watching us on TV get their commercials. So there's a little timer here and it says now you can continue. So I need to start two more of my machines. I have a XP client and I have a Vista client. And we use these two now for the discussion around SMB, Server Message Blocks version 2. We're going to look into what actually happens if I transmit files, and we use the same environment for talking about offline files. So SMB, as you know, Microsoft and many, many others, most enterprise file services use SMB. It hasn't actually been invented or created by Microsoft. It has been adopted by Microsoft, but it's an industry standard. And it's a really, really old standard which explains some of the limitations in there. If we think 10, 15 years in the past and think about how big has a normal file been 10 years ago, 15 years ago, then we are talking about kilobytes. Now today, if I create a PowerPoint presentation without me creating any slide, it's already 3 or 5 MB in size because of some of the background stuff we put in there, some of the formatting we put in there. There's so much stuff in the PowerPoint presentation already before I even put any content in. And the same is true for many, many other documents. If we think 10, 15 years in the future, if I were to tell you today that a normal Word document will be a couple of 100 megabytes in size, would you believe me? Which of you believes that in 10 years, a Word document, an average Word document with 20 pages will be 400 megabytes? No one? But if we just think the same growth rate and continue 10 more years, we'll exactly end up there. I hope we won't, but if nothing changes, we might. So 10 years back, creating SMB, it's actually more than 10 years back, creating SMB version 1 was a very logical thing. There was nothing wrong with that. It's just that people didn't assume the growth rate we were going to see. Now, if I want to open my 5 megabyte PowerPoint presentation over a certain link with a certain bandwidth, what is the formula that will tell me the amount of time that this is going to take? Any guesses? I need to wake you up. You are digesting your lunch, which is great, but I need more interaction. What's the formula? Any guess? I'm opening a 5 MB document, whatever it might be, over a link with a certain bandwidth. How long does it take? Should be size of the content divided by bandwidth, right? A lot of nods, okay. I hate to be the bearer of bad news, but it isn't. There's two things that we need to keep in mind. One, what is the application that we are using? Let's assume we are using some older version of Microsoft Word. Now, Microsoft Word is really, really smart. It knows that we are no longer in an environment where every user has their PC and they are not interconnected, so any document can be accessed by one user at any point in time only. Word knows that we are in a connected world. So we have to check if anyone is messing around with our Word document before we actually allow any user to work with it, right? So we open the Word document, which means we have to transfer the data, all of it. Then we run a hash across the header of the document. We store that hash, we close the document, and we open the document again. We run a hash across the header, we compare the two hashes, and if they are different, then we know someone else is changing that document. So we should keep our hands off and open it read-only. If the two hashes are exactly the same, then we know no one else has changed that document. Great, but Word is a really, really, really smart application. So it knows doing that twice, well, that could be a coincidence. Let's do that a third time and a fourth time and actually 50 times. And now we are really, really, really sure that we are the only fellows wanting to open that document. So using that old version of Word, which is just one of many possible examples, means we are not only transferring the document once, we are transferring the document many, many, many times. So that's the one thing that tells us that this simple formula we were talking about can't be right. The second one, and we are going to switch over to the XP machine here now for that, is the way that server message block actually works. Now, one thing you can notice about Hyper-V is we changed the way you use the virtual machine remote connect window a little bit. You don't have to type in this wonderful URL that you know from virtual server anymore. Let me actually put this to full screen and close that Excel sheet. We are going to use that Excel sheet later on, so don't worry, I'll explain to you what that is. And we are going to close these folders. And now what I did before the session, I trust you believe me that I did it before the session. I'm not going to repeat that for the sake of time. I have a 2 GB ISO file on a Windows Server 2003 virtual machine here, and I have just this Windows Server and the XP client on the virtual network, and I just dragged and dropped the file over and had Netmon run in the background and captured the first couple of 100 frames. And I saved them on here. And this is Netmon 3.1 actually, so it is going to show us the frames right now. Here they are. You see it's all the traffic, so I'm going to do two things. First of all, I'm going to just right-click on SMB and say all the rest is really, really highly fascinating, but all I want is really SMB. So that's that. And then I'm going to add two aliases. So one of my machines is 0.1, and that is my Windows server. And the other one is, and that is my XP client. And we are going to say apply, and we're going to find out if I made any typos. No, I didn't. So this is actually what happens from the SMB side of the house when I do a drag and drop. Now remember, when I started that trace, I already had my two Explorer windows open, the Windows Explorer, the File Explorer. So I already was authenticated, I already pulled the whole list of objects because it was actually displayed for me, so this information got across the wire already. All that is done, and now I did a drag and drop. And the first thing that happens over there, if you look at the description to the right, is I have a session setup, which means SMB now says, I don't actually care that we already have a session. Things might have changed in the meantime. You know, whatever, the server could be dead, there could be someone having taken away your permissions, that all makes sense. But the fact remains that we now have to set up a session, which is one request from the client to the server and one answer from the server to the client. So that's one round trip. Then we have a tree connect, which means now that I have a session, I actually want to copy that ISO file from a certain location. So let's connect to that location and make sure it's still there. I have a certain path that got stored somewhere when I made the click for the drag and drop. Now that path is being connected to within that session. That's another round trip. And now actually you see it's one round trip, but I get 3 different answers from the server because the server now says, okay, I can give you that path over 3 different protocols. Let's see which one you will understand. You know, that adds a little bit of overhead here, but it's still within one round trip. And now that we have connected to the path, we need to share some path information. Do we actually have access permissions to the object that we want to transfer? And then there are a couple of more round trips, we won't go through all of them now, that actually say, okay, we want to copy a file, which means we first need to create an empty file in the destination, on the client. So we need to pull all the file information, create an empty file on the client, and then start transferring the data over. And if you look through what happens here, that is from the server to the client, from the client to the server and back, to the server and back, to the server and back. Each 2 lines are 1 round trip each. And there might be little time being passed in between, but normally if you do this over a link with some latency, then you will see that if a request comes into the server, it will answer in the same millisecond. The only time really being passed is when the packet transfers the wire. This is where our latency comes in. Now we are going to just skip ahead. And this is where it gets interesting. Now you see all that we've seen so far is just overhead. Everything from here, from the beginning to down there. All those round trips are just overhead, which is quite a lot actually. So from here on, you see that the word offset appears. That is when the client, XP, now tells the server, okay, we agreed on everything, I've created that empty file with all the correct permissions. Now actually let's move some data across. And you see now that it says transfer 61,440 bytes of data from offset 0, which means from the beginning of the file. And you will see that going into the server and the server firing out those bytes at the same millisecond. But this is 1 round trip. And then actually the client sends back a hash of that data to the server so the server can figure out if all of that data arrived in a consistent way or if it has to resubmit the data. In this case, everything went okay. So this is the data going to the client. And now actually things get out of order because I don't have any latency on my virtual switch. So actually this is the next package where the client says, okay, no, I have the first 61,440 bytes. Send me the next ones starting from that offset because I have those already. And so on, which means SMB, and that is the critical point, actually segments the data that it has to transmit into those packets with this fixed size. This is not negotiable. Roughly 60K of data is being transmitted in one go, and every 60,000 bytes of data is 1 round trip. So now our formula is no longer size of the data divided by bandwidth. It's actually size of the data I want to transmit divided by 61,440 bytes times latency. And that is the reason why SMB is so damn slow over high latency links. It doesn't actually matter how much bandwidth you have. We don't care because we don't utilize it. The only problem with bandwidth is if you don't have enough. But I haven't seen any customer so far that would have not enough bandwidth for SMB. Now, packaging our data in so small bits and pieces, we really don't need much bandwidth for that. So what we do with SMB2 is 2 main points. 1, we now have compound packets. That means all this long list of overhead that you saw at the beginning, most of this we can put into one package. We can now go from the client to the server and say, dear server, we want to use the existing session and we want to copy that file and we need the file information for it. So can you please give us everything we need? Thank you. And the server can then respond to us and say, dear client, I know you are authenticated and the directory is still there and here is the file information and please tell me when you're ready. Thank you. You see, we are also very polite now. We always say thank you at the end of the package. So now we have less overhead. The second thing is we don't use a fixed packet size anymore. We don't transfer 61,440 bytes at one go. We actually look at what latency do we have, how congested is the network, what's going on there. So what's the optimum value? If I do that same thing in the same environment with a Vista client and a Windows Server 2008, actually the packet size will be smaller. The reason being there is no latency whatsoever within one virtual environment here on one virtualization host. So the algorithm then determines, well, if there is no latency, I actually can do smaller packets, because if I have to resend something, I don't have to wait an awful lot of time. In a normal network where you have some latency, say I did some testing with a latency of roughly 30, 40 milliseconds, I actually send 1 megabyte of data in one chunk. So now if I open my 5 MB PowerPoint, the algorithm then is 5 MB divided by 1 times latency. So I'm talking about 5 times my round-trip latency, and that is not a lot of time to actually transmit that data. So now with Vista and Windows Server 2008, we are really able to scale for high latency links, and we are really able to utilize that bandwidth. Another thing that we did in SRV401, which is interesting for many environments, is durable file handles. How many of you have wireless LANs in their companies? A lot, okay. How many of you with wireless LANs actually use notebooks and run around over a corridor, let's say from your office to some meeting room, and then sit down with the running notebook in the meeting room? Okay, still a lot. So what happens before Vista and Windows Server 2008 is you have a file handle, but on your way to the meeting room, you actually pass 5, 10, 15 access points. So actually, technically spoken, you lose your connection to the corporate network, and you get a new one, and you lose it again, and you get a new one for each single access point. But your file handle to any open files will be discarded the first time that you lose connectivity. And then depending on the application that you use, the application will initiate a new file handle. If you do this with Word, for instance, then Word will say, okay, I lost my file handle, let's try to get a new one. So you won't actually see a lot of this unless you do a background save or something the likes the moment you lose the file handle. But it is actually depending on the application to do that. With Vista and Windows Server 2008, we don't do this anymore. The operating system itself, the protocol SMB, will re-establish the file handle if possible. If possible means if I don't go to another room within the same building, but I actually go across the yard into the next building. Well, I don't have wireless coverage in between, so I'll actually lose my file handle. I get a timeout. But if I don't really get a timeout, then the operating system now will re-establish the file handle, and my application doesn't have to take care about this anymore. So with that, let's finish off with transactional NTFS and SMB 2.0 and move on to offline files. And we use the same notebook here that I have. It's a virtual notebook. That's something new in Hyper-V as well. You'll see what I mean. That's a virtual notebook. And what I do is, first of all, I wonder what my mouse has done in the meantime. Okay, there you go. I have an XP machine, and I have my documents. And I'm using offline files. You can see from those little blue double arrows that all of this is replicated. I can actually go into the properties of my documents, and you will see the server path in there. You see, make available offline is grayed out. I've set a policy which forces offline availability. And as I said, in the properties, you see the path to my Windows Server 2003 and the IntelliMirror folder in there. And I also use a couple of other stuff on that server. I have a file share with the nice name Ralph's Data, and there's stuff in there. Amongst this is the Excel sheet that I just showed you. Now, all of that is available offline. So having a virtual notebook, we are just going to undock this. Now, this is another really distinguishing feature that we have. We go into the settings of our XP client, and we go to the network adapter over here. And now we tell the network that we are not connected anymore. So that's it, we are now undocked. But all of this is available offline, so that doesn't really matter, right? So let's close this one here. And we can open some document. And this is the Excel sheet you saw at the beginning. Actually, my wife and I, when we moved to Munich a couple of months ago, we used that Excel sheet to evaluate the apartments and see which one do we want to rent. So all of this is data from apartments that we looked at, all color-coded automatically and stuff. So this is all offline now. I'm not connected to the server. And now I'll sit down in the meeting room and plug in a network cable again. While the document is open, shouldn't be a problem, right? It's all available offline. So one of the bugs in Hyper-V is now it says the network is misconfigured when really it's not connected. So don't worry about this. We are reconnected now. And if you look at the client, then we'll see now it is connected. That is great. And in just a second, down here, we'll see that the server, the IntelliMirror server, is now available again. You saw that now the little blue eye popped up, which now says, okay, your IntelliMirror server is available. Now, I don't really care about that server being available right now. I want to use that Excel sheet. It's already open, so why should I care about that server? But in fact, you know what? I need something from those other files in that folder, in that share Ralph's data. Remember, that's on the same server. So let's open that. So that's on that server. And whoops, there is it. You saw it before, it was there. So my admin must have deleted that folder. Why? Now that's weird, isn't it? Now the reason behind that is, if you have offline availability and you don't go online once your server is becoming available, then we will assume the entire server to be offline. And we won't show you any single share except the one that is waiting for you to go online. Now the normal user doesn't know that. The normal user will now call the IT and say, my file share is gone. And the IT will look at the server and say, no, it's there and you have permissions and something must be wrong with you, you know, clean your glasses or something. The file share is definitely there. But we being technical users, we know that we just have to go online. Okay, so let's go online. We have this over here, and we can go to the status, and there it says, okay, go online. And okay, we'll go online. Oops, it says, you can't go online. You have a document open. Well, too bad. Let's just close the document then in the background. And then go online. The bad thing now is with all of this is XP and Windows Server 2003, we synchronize on a file level. So that was one file and no latency. Imagine I did a couple of edits and the file is really big. I will have to wait some time now, right? So I'm online. The share still isn't here, right? So now I can close and reopen the folder, or don't know if F5, actually yes, F5 shows it. So now I can go to my documents. So these are all limiting factors for offline files with XP and Windows Server 2003. If we actually move over to my Vista client, real quick, and we look at the same thing. Now there I have it open. And we go to full screen. Then in the right bottom corner, you see that green circle with the double arrows. That's the sync center. And now whether I'm offline or not, offline or online, in documents, I have actually the same documents. And let's open that same Excel sheet. And it's going to give me an error message now, probably yes, because I did not activate Office. So what it says is 23 more demos and you'll run out of chances. So there's my Excel sheet and I'm online now. Let's do the same thing here. I'm going to undock my client. And the moment I do this, and just set this to not connected, the file handle that I had to this document that was to the server actually because I was online but it was using the local cache, is now reverted. You know, the server is no longer there. So I can continue to work with the document. I just lose my remote file handle. But as I open the server from the local cache, nothing changes to me as a user. Remember in XP, if I open a document and my IntelliMirror server, my documents folder is online, I always open the document from the remote folder, which is a problem for me. I'm based in Munich in Germany. If I travel to the US with an XP notebook and I'm in the corporate network, then all I do with my documents content is from my document server in Munich, and there is something like 200 milliseconds of latency between Munich and Redmond. So that's going to be real slow. With Vista, it doesn't happen anymore because I'm using the local cache. Even though I do have a remote file handle, I just have two file handles. I need them for security reasons. If I want to sync back to my documents folder, I better have permissions. So I need a file handle, but I use the local cache. So now I'm offline. I can do whatever I want with that document, and I can simply go online again. And the thing that you'll notice once I go online again is that you won't notice anything, which is exactly what I would expect if I were a user. Now we go back to that Vista machine. There's no pop-up, there's nothing. It just goes online. It just uses the local file handle and transfers it into a remote file handle. It continues to use the local cache. It's going to synchronize the delta, not the files. We now use the DFSR mechanism, DFS replication mechanism, to synchronize the delta to my IntelliMirror server. The server immediately becomes online available for us. All the shares are visible because now we determine availability, are we online or offline, on a per file basis, not even a per share or per folder basis, a per file basis. We don't care about the rest. If you want to access something, we just look up if it's there or not, and we don't care if anything else on the server is there or not. Doesn't make sense, so we stop doing this. So much for offline files. I have to have a glance at the watch. We have around 5 more minutes, and then I want to move into question and answers. So, excuse me, we will use those 5 minutes to talk about 2 more things. One is DFS replication, and the other is this one bit around clustering that I mentioned before. Let's actually start with DFS replication. Who of you is using DFS replication from Windows Server 2003 Release 2 already? So that's about a third, I'd say. So for the sake of the rest, let me spend a minute to explain the differences. File replication services have been around for a long time. And before Windows Server 2003 Release 2, if you wanted to use replication, then first of all, you had to set up DFS. You couldn't do file replication without DFS. You could do it with NT4, but that's a long, long time back. So with Windows 2000, Windows 2003, you had to use DFS, and then you could use the file replication service. Now, this service has some very nasty habits. First of all, it's replicating on a file level. Now, imagine you have a user with a PST file from Outlook, and that PST file, mine always are like 1 gigabyte to 2 gigabytes in size. So I open Outlook, I close Outlook, I didn't actually change anything to the file, it just has a new timestamp, so it gets replicated. All the 1 or 2 gigabytes, it's replicating on a per file basis. Then it has a really, really poor algorithm when it comes to the target and the destination losing touch with each other. Above a certain time threshold, which is just a couple of minutes, I think around 5 minutes at most, if the target and the destination can't see each other over the network, and you boot a file server, that's it most of the time, then the destination just moves all the replicated content to a hidden folder, and then compares what is in the target folder with the contents of the hidden folder, file by file, and if anything changed, it obviously gets replicated again. But if you have a DFS structure pointing to 2 physical paths, then the users at the one end will see the content, and the users at the other end will see nothing, because it just gets moved to the hidden folder. Can be quite confusing for users. So there are a couple of other limitations, like the scheduling was dependent on the scheduling of the Active Directory replication. If you said your Active Directory is replicating every 15 minutes, then file replication service would also replicate every 15 minutes. So your file service suddenly became dependent on some attributes of your Active Directory. Now with DFS replication introduced in Windows Server 2003 R2, and there's not an awful lot of changes to Windows Server 2008 to that, is the biggest change is we are replicating block level, not file level. The second is we have a very, very good compression mechanism. We use remote differential compression to determine what's the absolute minimum that we have to transfer. For instance, if you move a file from one directory to another, or you copy it from one directory to another, using Windows Explorer pointing to a remote server, before we would have to actually transfer the whole packet from the server to the client to the server using replication. Now all we do is we say it's already there, we just move it on the back end, we don't transfer it over the wire at all. Or if you actually open a file and you do some little changes and you save it under a different name, we actually say, well, all we have to transfer is the changes you did. Although you opened the whole file in your application and you save it from your application, we don't actually transfer it over the wire because we say, well, most of that's already on the back end and we just transfer the delta and build a new file on the back end. So it's some of the most significant changes. Other benefits include you now have a topology and a replication schedule that's completely independent from anything else you do. Plus, as I mentioned before, you now can replicate without using DFS, and you obviously can use DFS without replicating, or you can do both or none. So that's the changes in DFS from Windows Server 2003 before R2 to Windows Server 2008. And the last topic for me today is high availability and clustering. So cluster services also have been around a long, long time, and there always has been one particular nasty bit which many users have told us, well, it's all nice that you do, but you know, this one bit prevents us from actually using it in a production environment. This bit has been how we use the quorum resource, the central shared cluster configuration database, to negotiate what a cluster does in certain circumstances. Now, cluster essentially is a mechanism that has to do one thing, has to do a lot of things, but one thing interests us here. That is, a resource living on that cluster node that is dead for whatever reason has to be brought online on that cluster node over here. Which means, in turn, that all the cluster nodes have to be able to run all the clustered resources. You can limit that in some way, but essentially that's it. All the nodes have to be able to run all the resources. Now, that's okay unless those nodes stop talking to each other. If the network connection between two cluster nodes is broken, then both of these nodes would think that the resources that are alive over there are dead because it doesn't see them alive. So let's bring them up over here. And this node would do the same thing and try to bring all the resources that are already online here up on this side. And so in the best case, you would simply see resources bouncing online and offline between the two nodes because they are chasing for access to the same LUNs, for instance. In the worst case, you would have total corrupted volumes. So that is something that has to be prevented, and the way we do this is we use one single resource, the quorum, a copy of the cluster configuration database on a shared storage, and we say, well, a cluster node that either owns the quorum, and owns means from a SCSI point of view, I have a SCSI reservation to the quorum, and I renew the reservation every couple of seconds. So I own the quorum, then I can bring resources online, or I know someone, I can talk to someone that owns the quorum. Then I can also bring resources online. If I don't own the quorum and I don't know anybody that owns the quorum, then I have to immediately bring all my resources to an offline state. Now imagine that you run a big data center and you have a 16-node Windows Server 2008 cluster with virtualization on it, and you run 1,000 production machines virtualized on that cluster, and that one single resource, the one quorum resource, for whatever reason goes offline. Now all my cluster nodes say, well, I don't own the quorum, I don't know anybody who does own the quorum, I don't have any reason to, but let's just move those 1,000 virtual machines offline. There's nothing wrong with those 1,000 resources, but the quorum isn't there. So now you might think, why should the quorum go offline? There are really interesting ways to bring a quorum offline. My favorite is, and I've seen that happen a couple of times, use a quota software and put a quota on the quorum file. The quorum grows over time. At a certain time, the quota will be full. If your quota software then denies write access to the quorum file, that's it. Another favorite of mine is clean up your NTFS permissions on the LAN, on the volume where the quorum is hosted. Just remove access to the cluster service account. The quorum will be offline. There are other ways that you can bring that offline, but the point remains you have one single point of failure for your entire clustered environment. And that's not acceptable to most customers. So we said with Windows Server 2008, we'll move away from that. You still have the quorum. You can, for instance, use a file share instead. We call it a file share witness, which can fulfill the same purpose, but can be independent from your cluster environment. Or you can say, I don't care about any centralized resources. I just use the number of cluster nodes in my algorithm. I say if the majority of the cluster nodes can talk to each other, then they form a healthy cluster, and the rest will move their resources online. Or you could say, if all the cluster nodes can't talk to each other, or at least one part of the cluster stops talking to the rest, then all the nodes simply keep running what they used to run at the moment, and failover isn't happening anymore unless an administrator initiates it manually. So you retain the control over your environment, but the cluster is prevented from doing any harm to the resources. There are some other changes we did to clustering in Windows Server 2008. One of the most significant ones, besides the change to the quorum, is we now use SCSI version 3 exclusively. The reason for that is in SCSI version 2, there's one thing that you couldn't do, and that is a targeted reset. A targeted reset means I have a shared storage environment, and for instance, you have file servers, those have LANs, and you have some tape libraries for backup. Now, each of the resources, each of the tape drives, for instance, are SCSI targets, and if you want to reset any single one of these, now that's difficult because there is no such thing as a targeted reset in SCSI version 2. But there is tons of pieces of software out there that think they could do a targeted reset. For instance, backup applications quite often try to do this. Now, the fun of the thing is, if your application says targeted reset of that tape drive, that translates down the storage stack until the SCSI 2 driver says, I don't know what a targeted reset is, but you know what, I know reset. I don't know targeted, but I know reset. So I'm going to assume that the application up there just meant reset. And then it will send a reset, and that will actually reset all of the storage targets, all of the SCSI targets that are visible, not owned, but visible to that host bus adapter in that specific example. And that means that all your LANs and all your tape drives and everything that you had online from a SCSI point of view suddenly disappear. Depending on the applications that you use, they might eventually reappear or they might not reappear. Really depends, but we could not do a targeted reset in SCSI 2. Meaning not Microsoft couldn't do it, but there is no such thing in SCSI 2. In SCSI 3, it does exist. That's the reason why with Windows Server 2008, if you want to use clustering, you have to have SCSI version 3 storage hardware. SCSI version 2 hardware is not supported anymore. So with that, we have around 7 minutes for questions. And there are microphones at both sides of the room. So if you want to raise questions, either please go to the microphones or just shout them loud and clear, and I'll try to repeat them for the rest. So are there any questions? Yes, please.
What about check disk with clustering with 2008?
What about check disk with clustering with Server 2008? Well, two parts of the answer to that. First, self-healing NTFS means we don't require check disk for most cases. We try with self-healing NTFS to repair things on the go, and only if that doesn't work at all, if for instance we can't block some part of a volume which really got corrupted and messed up and wait till the next reboot, stuff like this, then we require you to run check disk. Now, the second part of the answer is if you do have to run check disk, obviously you have to then wait for the next reboot to do it. But check disk is now way more performant than it used to be. So especially in clustered file sharing environments where you have volumes with huge sizes, you had to wait hours sometimes, depending really on the fill rate of your volumes, on how many files you had on there, how much corruption you had on there. That should be way faster now. I believe you were first.
Hello.
Hello.
The offline files that you mentioned and the way that they sync up, that's mentioned as a benefit of Vista. Does that require 2008 as well, or is that just with the Vista client?
For the offline file functionality that I demonstrated, you will need a Vista client and a Windows Server 2008 to get the full functionality. Vista itself contains the sync center, but to sync deltas and have the file server understand what to do with that and to transfer file handles back and forth, you will need a Windows Server 2008 in the background.
Okay. I was also wondering whether there were any plans to retrofit SMB version 2 to Windows XP?
Well, let's put it that way. Officially, SMB version 2 is available with Vista and Windows Server 2008 only. With RTM of Windows Server 2008, I believe that won't change. Unofficially, we heard the message loud and clear, and I believe it's not a question of if, but a question of when this will be available for XP. But there is no official plan, there is no official deadline that I could communicate to you at that point.
Thank you.
Please.
Okay, regarding SMB file transfer over slow links, there are on the market some hardware producers that give us tools, something like Packeteer or Cisco WAAS, that basically do a lot of stuff, but even accelerate traffic, SMB traffic over one links. What is new in SMB version 2? Is something better than these guys produce, or is something less? Because they also have coverage in other stuff, in web acceleration and stuff like that.
Well, that's a very, very valid question. Thank you for bringing that one up. If we talk about distributed file services, then the question not only becomes how does a remote user access a file over a high latency link, which is where SMB2 comes in. That's the huge benefit, one of the huge benefits you have there. The question also becomes, if I have more than one instance of a file, how do I handle multiple users doing changes to multiple instances of one single file? And what happens if that replicates? With DFS replication and SMB2.0 exclusively, no Packeteer or any other caching software on that, what happens is the last writer wins. So I have a Word document in two places. I change it here, you change it there. I save it, you save it last, you win. My changes are simply overwritten. The reason being that the file server is not a Word server. It doesn't know about Word, it doesn't know about contents of Word. It just knows about NTFS and SMB and stuff like this. So it just says, well, the last one that saved it, this one is what I'll keep. So what Packeteer, for instance, adds onto this, and this is not something we do out of the box for Vista, Windows Server 2008, for instance, is caching. And caching with Packeteer is a brilliant solution because then it no longer depends on the application to figure out how to handle these conflicts, but the Packeteer solution will hide the multiple instances of one single file from the applications and from the users. Think about it as data virtualization. You can replicate the data, it integrates with DFS and data protection manager and stuff like this really nicely, but the application doesn't need to think about there's two Word documents now and I need to make sure we don't have conflicting changes. So I access a file, there's a caching server in between me and the file, or the multiple instances of the file. That's cool. Packeteer actually uses TCP/IP and not SMB to transfer the file, so there's a little less overhead even in this, but with SMB2.0 the difference isn't quite as significant as it used to be. It's still a little less overhead. But the main thing is the caching server is now going to talk to all the other caching servers, and if you open the same file over there, then your caching server is going to know that my file is already open, and your application will not see a second instance of the file, but your file handle is actually going to point to the same file. So either it's an application like an Excel shared workbook or an Access database that is able to work with multiple users on the same files, then this is what's happening, that works. Or it's an application like Word, and then you are going to get read open. Although in a DFS infrastructure, you might actually see another instance of the same file, but your caching server is going to take care of that for you. So that's the one of the really, really cool things that a solution like Packeteer adds to the file service.
Okay, are you thinking of integrating this feature in the next release of Windows Server? I mean, I don't think it's a brand. It's been around for a couple of years now, and I'm sure Microsoft has some guys that could tear apart the bits and pieces and put it into a new service pack or something like that to be embedded in the Windows Server. I don't see why do I have to buy some extra hardware equipment just for that.
Well, you don't actually have to buy extra hardware equipment for Packeteer. Packeteer is a solution that has been developed in very, very close relationship with the Microsoft Storage product group. So it's not from Microsoft, but Packeteer and Microsoft work really, really closely together. Now, keep in mind, Microsoft is a platform company, and we always depended, and we will always depend on this huge infrastructure of solution providers like Packeteer and many, many others adding value on top of our platform. And as time goes by, obviously we bring more and more of these values into the core operating system, while those solution providers like Packeteer, like Citrix for terminal services and others move on and break new ground. So it's always them moving ahead and we taking stuff into our operating system. Eventually, I'm sure this will be part of the operating system, but it's not like we want to take over this ground away from Packeteer and say, we steal your customers or anything like that. They will always be partners, and we always depend on our partners to add value. I see a red light flashing over here. I don't want to be rude, but we have to round things up. I will be available for some more minutes over here. I'll be back at the Ask the Expert area if you do have more questions. Other than that, thanks for your attention. Have a safe trip home. If you're departing now, I hope you had a great week. I certainly had one. And see you around next time. Thank you.